See.
So you got to find the second derivative. Don't let me forget. Pay attention to your notation so that you know when you found the first derivative or the second derivative. The first derivative, just a power rule. Don't be afraid of those fractions. They're not going to go away. Multiply 8 times 5, which is 40 over 9. X to the, subtract 1. When you subtract 1, in your head you should be seeing 9/9 instead of a 1. So 5/9 minus 9/9 would be a negative 4/9. Okay? Now, since that's not my final answer, I'm not going to bother to pretty it up and give it a positive exponent yet because I still have to do another derivative. Okay, are you with me so far?
So you continue doing that?
Yeah, so now I'm going to do another derivative. That's what the second derivative means. You must have missed one of the videos. So now I do another power rule. Negative 4/9 times 40/9. 4 times 40 would be negative 160. 9 times 9 is 81. These are lovely numbers. And now I need to still subtract 1 in the form of 9/9. So I'm going to subtract 9/9 from negative 4/9, which is negative 13/9. Final answer, though, you can't have a negative exponent. So we're going to move the x to the bottom and make it a positive 13/9. Okay? Second derivative just means the derivative of the first derivative. Okay, so you can work it as an STD and split it up like this, or you could have done the quotient rule. If you do the quotient rule, I think it's a little uglier. The distributing is a little harder, but they both would, of course, work. I think it's easier with an STD. So I split it up, but now pay attention to your notation because you do a lot of math without doing a derivative, and you might not realize you haven't done any calculus yet. So right now I'm still just doing algebra. So now I'm going to simplify this. The first term, x to the 5th over x to the 4th, that's just an x. This guy is simplified, but in order to do the derivative of it, I need to make it a power. So I'm going to move the x to the 4th up to the top and make it a negative 4. But notice I haven't done a derivative. Now switch symbols so that you make sure you're doing the derivative and you get used to seeing that symbol when you're done. Otherwise, you sometimes do half and half because you get it confused. Now the derivative of x is 1. And the derivative of the second term is going to be positive 36. X to the subtract 1, and you get negative 5. And rewrite that with the positive exponent. So my final answer would be 1 plus 36 over x to the 5th. Now, let's say you look at it. I have two separate terms, okay? But let's say you look at the answer. If it's a free response question, this is fine. It's simplified with positive exponents only. But what if I then say, and I think I do on this one, I can't remember. No, I don't. What if I then say, write your answer with only one fraction? And I kind of made this go a little too far. Hold on. So how would I get a common denominator of this if I had to? Again, if I don't say that you have to, then you don't have to. You can leave it like this. Okay, but if you are looking at your answer and you don't see it like that, then common denominator, that just means change this 1. Okay, multiply by an x to the 5th on the bottom and an x to the 5th on the top. Now you have a common denominator. You keep it. And then rewrite all of that, x to the 5th plus 36. This is the same thing. That's basically the same as reversing the STD, okay? All right, now I don't know who I was talking to, so please answer me. I could be talking to nobody. I want you to know I can't see your faces at all. All I see is the whiteboard when I'm doing this. So I have no idea if you guys are making motions at me or anything. So tell me if that was real quick with number 9. They stuck a little negative out in front of the answer. That's the same as having the answer like this. But even though there's a negative 8 factored out or a positive 8 factored out, those would have both been correct. You also didn't have to factor the 8 at all because it didn't cancel with anything. So you could have really left this answer 3 different ways. But the reason you guys thought you had the answer wrong is they put the negative out in front of the fraction right here. It's just hard to see it. Whenever it said...
not sharing.
I'm not sharing right now? Oh, I failed to hit share. That makes sense. Okay, hold on. Now, am I sharing it now?
Yes.
Okay. I had already written it, and now it went away. Okay, this is number 20 from the review. Okay? When it says horizontal tangent, immediately write. That means the slope is 0, but you want to write it with calculus. The derivative is 0. On the AP exam, that's a point, and that's a lot. All right, so I'm looking for where the derivative is 0. So I'm going to find the derivative. The derivative of negative x is negative 1. The derivative of 2 sine x is 2 cosine x. And then I'm going to set it equal to 0. Okay, so I have now negative 1 plus 2 cosine x equals 0. Solve that for x. So first get the cosine by itself. Move the 1 to the other side. Divide by 2. And I have cosine x equals 1/2. Now that's a unit circle value. So I need to visualize my unit circle. This is the only one I ever remember, this guy right here. Okay, and it's alphabetical, cosine and sine. Well, clearly this is not a 1/2, so it's got to be here and down here. So I'm looking for this value and this value because my cosine is positive there. So what are those numbers? Counting by 6, 1, 6, 2, 6. 2, 6 is the same as pi over 3. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. 7, 6, 8, 6, 9, 6, 10, 6 is 5 pi over 3. And honestly, I should have looked at the question again to see when I should stop because I could keep looping around this circle forever, but they wanted the answer from 0 to 2 pi, so that's just one loop. Those are my two answers. Okay, was that too fast? Was that okay?